All right, so welcome to a tour of an all-electric solar shingle Amish built forever home. It basically says what it is. We're going to go into this home, meet the owner, see and hear why they did what they did, and have you ask your questions and hopefully inspire you to build and improve your home to make it better as well. Now, before we get started, this is a reminder that this tour is part of our ongoing American Solar Energy Society, or ASIS, National Solar Tour. You can check that tour out and all our other virtual home tours that we've been doing, including my own home, at greenhomeinstitute.org/ASIS Solar Tour. And with more being added this year as we go on. And I want to say a big thanks to our co-tour sponsor, Absolute Solar, for sponsoring our version of the tour. You can check them out for all your solar needs at absolutesolar.com for projects located within Michigan. Also, a shout out, ASIS wanted me to remind you that their Solar 26 conference call for participation papers and being a speaker is well underway, and you have until February 2nd to submit your application at asis.org/conference. So again, welcome to a tour of an all-electric solar shingle Amish built forever home. This session is brought to you by the Green Home Institute. The Green Home Institute is a nonprofit with a mission to empower people to make healthier and more sustainable choices in the renovation and construction of the places we live. We are a small but mighty team of two. Today, I will be your moderator. My name is Brett Little, and I am the education manager here at the Green Home Institute. Like all of our sessions, this session is approved for multiple continuing education units, including all 5 pillars of green and our certified green home professional designation: energy, health, materials, place, and water. AIA Health, Welfare, and Safety may make it applicable to your state-based design or contractor license. And then look for that 5-digit passive house code sent to you at the end. As long as you're here for the entire CU approved hour, you will receive that within your CU certificate. So with that, I am excited to hand this off to our speaker here, Joe Deedon, homeowner and our tour guide for today. So Joe, glad you could join us. Welcome, and please take it away.
Hey, Brett. Thank you. I'm not a veteran of doing these things, so going and moving around and sharing could be kind of interesting, but please bear with me. I'm going to do 3 things today. I'm going to show some numbers of our data over the past 3 years, show you a video which gives you kind of a context with the look at things, and then we'll do some Google slides. And I thought the numbers would be interesting in this time of uncertainty, political uncertainty, of looking at more severe weather incidences and looking at AI power consumption sorts of issues. But I wanted to show you a little bit about what the house looks like. This is our south-facing roof. We have solar shingles on both the garage and the house. The house is, you can see, 1,640 square feet. We have 2,260 square feet of the combined roof surfaces. That gives us 32 kilowatts of direct current power and 26.6 kilowatts of AC power. And I think the most important thing is that, and I'm amazed by this myself, we designed a house around a roof. Did you hear that correct? We designed a house around a roof. We went through all kinds of iterations of having a steep south-facing roof, a one-pitch roof with a vertical north wall. But in Minnesota's winter climate, that would be your only really source of shingles windows and daylight. So we decided to go with the 2-pitch roof. We wanted a steep roof. This is 10, 12, or 40 degree roof because we wanted it to work with snow removal in the wintertime. And we wanted no penetrations on the south-facing roof. So those were our our main guiding concepts. And on this photo, I put this in just to show you that this is the shingles with frost on in the morning as they're warming up. So as the shingles are warming up, they're melting down to this black surface. But you can see around the edge, there are dummy shingles, a whole shingle, half shingle, whole shingle, that they use over the overhangs and on the perimeters of the roof. And then the functional shingles are in the center. So I wanted to start off with, we have 3 years of generation data. We moved into our house in February of 2023. So January data I do not have. And what I did to give me annual averages, I went back in and took the average for the previous or the following 2 years and used it as my average for January. So you can see in January, I took the average of these two and put it up. Same thing on home usage. Moved it up 3,000, so all the way down. My January usage figures are the average of the following 2 years. And looking at this, we have, as I said, a 1660 square foot house, 2260 of roof surface, but our roof produces, we're in the top 1% of solar production from solar roofs in the country, which I think is pretty cool. That we get our most production in July, which is no big surprise there. And pretty interesting, I kind of was looking at, March, things really kind of warm up and it performs nicely. And December and January are just kind of the pits that we struggle to get through. When we have the home usage, so it's a passive design house. We have super insulated walls and ceilings. We have access windows and doors. So it doesn't take a lot to heat and cool our home. Our largest energy use is the car charging. Our second largest use is heating and cooling. And third largest use is our water heater. So you can see, and this is not surprising, January is a high use month, and also August. I was somewhat surprised by that. I thought normally in Minnesota, air conditioning still costs more than winters, but we had some tough Januaries. This is car charging data of how much do we use to charge our car. And it's not significant, but I thought you might find this interesting. We have a Model 3 car with 155,000 miles on it, and we average about 450 kilowatt hours per month to charge the car. And our rate is 10 cents a kilowatt hour, so we're paying $46 a month to charge the car. Now, this does not include line charges or other fees that the electric company adds on. This is only the cost of the electricity. But $46 a month to have a full tank every morning when you're ready to go somewhere. If you're looking at home usage without the car, here we go, that July is our highest use month. And this data is something that Brett said you can access in the chat comments, so you have this to look at your leisure a little bit later on. We have an air to water heat pump, and we use that for heating and cooling. And I'll have more information on that as we go through the slides. Heating has worked fine. Cooling has been more of a challenge. So remember, this is in-floor cooling. And this is to heat and cool our house, $179 a month for heating and cooling. Once again, that's electric only, no line charges. So when we get down to exporting data, we are in the top 1% of homes exporting electricity on solar roofs. And somewhat it's kind of interesting. I think it's more on the shoulder seasons of getting export more, but actually I'm getting ahead of myself. When we're exporting more, you can see those times a year. Importing, we import in December and January. We have a battery backup that helps out on this. And then this is net use. So December and January are hard months for us, and June and July are good months. So this is all the monthly data that you can take time to look at if you want. Here's the annual data to see how things compare. Our backup history, we have with a smart electric panel that controls our battery. In 23, we had 5 outages that lasted a total of 40 minutes, 2 in 24 lasting 11, and 3 in 25 that lasted 17. This is the schematic of our solar design. You can look at that of shingles coming down into inverters, going off to gateway, coming back into the battery backup and off to the grid. And if you're interested, there's a video I'm going to play next, and you can scan this QR code, which takes you directly to the video. So you have all this data to look at, and I'm going to try to move on to the video. The video sound is not working, so I'm going to give you a voiceover as we go through this video. And we'll see how well I do with that. Lanesboro, above the Root River, where we're located in southeast Minnesota, hour south of Rochester, an hour west of La Crosse. This is our home. My wife and I talking about the home that we try to make it a retirement home that will serve us for the long term. There's our dog. Talking about the design values, passive house, other things that we want to get a view of the roof. Solar shingles only on the south side, the metal on the north side. Good look at the roof. There's our backup battery. It's 13.5 kilowatts. The floor plan of the house, 1660 square feet. Our car, notice the name on the car. We tried to design a solar all-electric home. These are the guys that did the installation for us. It took a day and a half. We positioned the house on the site. So we went on, when we decided to buy the house or build a house, we went on Google Earth and looked at potential south-facing building sites in Lanesboro, the city we wanted to build. Then we got design software, and we positioned the house optimally on the site to capture the most solar energy available to the site. So just remember that. We designed a home around a roof. We picked the best solar site. We optimally positioned the house on the site. Let's see if we can keep playing. There's our solar. These are the dummies that I was talking around the edge. What our information is that's available. Here's another one. So when we're talking about positioning the home on the south, this is to the west, and you can see this large walnut tree, which we wanted to keep, is shading the south-facing roof early on during the day. We have a smart electric panel, which has paid for itself right away. You'll see more of that in the slide presentation. The data that's available from that, we charge our car. Like I said, it's nice to wake up with a full tank every morning when you want to go somewhere. You can see the information coming off the roof. Here we are looking at saying that water heaters are third largest heating cost, and the roof. We have an Arctic air-to-water heat pump, so it's not air-to-air, it's air-to-water. It was interesting trying to find contractors that were willing to install it. It's worked very well. We have 5 zones in the house using in-floor heating for both heating and cooling, as I said. This talks about the power going from the inverters out to a gateway, coming back into the house. Our air handling system is a small Swiss system. The nice thing about it has exchangeable filters, variable speeds. It's a small tubes in the wall system. Has worked very well. There's our shoulder shingles being installed. It took them a day and a half, and it was a flawless installation. Once the shingles are installed, the electricians get to work on hooking it all up, making sure that each run of shingles here is working, that it comes down into the inverters. It was done in mid-October. So this is power coming down off the roof going into the inverters. We have 4 of them. And it goes out into the gateway. And this is monitoring solar production, where it's sent back into the electric panel in the house, off to the grid, or down to the backup battery, which is 13.5 kilowatts. The battery we use to offset our grid use during the day. So we draw it down to a certain percentage in the summer and the winter to limit the grid use. During storm events, it backs up to 100%. So this is initially our home produced 4,000 kilowatts a month, and we sold an average of 2,000 back. We're still selling more back than the house uses if you take away the car charging. So I think that's what I wanted to show on that. And then the other one we have is a slide. And as Brett said in his promo material, it was interesting in working with these people about getting people who wanted to build a house to be part of our design team. And as I said in my data, that we were in the top 1 of energy producers and exporters during the first 2 years that we had the house, showing that we produced 92 kilowatts and the house used 42, going to the grid. We got into this because we did a deep energy reduction retrofit in our previous residence. And this was done in 2011 and 2013. Originally, our builders here said it would take us no more than 6 months, and it solar imaging to make sure there were no leaks, cracks, or obvious heat losses on the building. And they were anal in this whole process to caulk and seal every crack and seam. They did an amazing job. And we came in almost with passive standards on a redesign remodeling project. So it was really pretty amazing. We learned all about energy efficient concepts, working with an amazing group of people. I'll show you at the end. The builders were into this and helped come up with the process that we wanted to use and the products that we used. As I said, we did infrared imaging. And that if you're looking at doing something yourself, you know, the low-hanging fruit is always to start with an energy audit to tell you where you're going to get the best bang for the buck on what you want to do with the money that you have. So in January and December, we really decided we're going to build a house because we had about 16 months to move out of our current house that you saw we did the retrofit on. And it took us 28 months, 10 days, and 4 hours when we ordered our car till we got it. So we knew that there were lead times involved in getting solar shingles. So when we decided in December we're going to build a house, in January, when we found out that solar shingles were available in Minnesota, we put a down payment on a house without having a site or a home plan. So have you heard that right? We put a down payment on solar shingles without having a site or a home plan. So then we're really motivated to get on Google Earth to identify building sites, of which there were 3. We talked to the landowners, and the most favorable landowner was willing to work with us on selling the site to us. Then here we are in April working on the design of the home with a design team that was just great and coming up with recommendations what to do. And finally, in May, we're going out and talking to construction subcontractors about doing electrical HVAC. The Amish builders were on from the get-go. They really wanted to do this building, but HVAC and electrical were a little bit more sketchy to get signed up. But HVAC wanted to do the air-to-water heat pump, and the electrical people wanted to do the solar shingles and the battery backup. So that worked out really well, and they all worked really well. We moved in a little bit more than a year after that we purchased the property with me as the building contractor. So I think all you guys are pretty comfortable with some of the things we used. We used ICFs on the walls. We insulated the basement. We have 2 zones in the basement. You can see the zones coming up. Poured floor will be. The construction materials we used, we had in-floor heating for heating and cooling, an exterior siding to seal the walls. And then I grew up on a farm nearby, and we tore down the barn and stored it for a number of years. And we used the barn siding and beams in the construction of the house. So we have barn siding on the breezeway, east deck, and in the garage. You'll see some photos of that as we go along. Our heating and cooling system is an air-to-water heat pump. It's worked out really well. We have 5 zones in the house heating. The challenge with air water cooling is in the floor is that it's determined and controlled by relative humidity in your house. So as the relative humidity in the house goes up, the water temperature in the floor is raised, so you don't have problems with dew point condensation occurring on the floor. So it works just fine with 2 old people living in a house, but if you have events going on, people coming and going, it gets to be more of a challenge. And as you have a large number of people, it doesn't work, and then the humidity rises and your temperature rises. So we put in a fan coil on the ground main floor that cuts in before the mixing valve. So we basically have about 40-degree water that we use for cooling. So this fan coil now takes care of primary heating in the summertime when our in-floor cooling system is overwhelmed by relative humidity. I hope that all makes sense to you. If not, we can talk about that later. This is our air handling system. These are the little tubes that do it. But what I like best about these are the small filters on the main unit. And we change, I change this one every 45 days. That's input. This is flowing through the system. I change that one every 6 months. This is a activated charcoal filter, and these are HEPA filters, and we change these annually. But it's really nice to have easily replaceable filters to keep the air supply in the house well. And in Minnesota, we've been having trouble with soot particles getting in from forest fires, smoke, and it's really nice to have HEPA filters pulling all that out and feeling comfortable in our house because of that. We have a whole house dehumidifier. The only problem I have with this, it's a little bit noisy because our house is so quiet, but it's a necessary evil. We have a smart electric panel, and that has worked out really well because you can control things remotely. It has primary, secondary, and tertiary circuits, so as power goes on and off, you control your power, and I'll have a slide about that a little bit later, but this is early on in March, so we moved in February, and in March, I was looking at the data, and you can see our primary heat source was using 8% of the power, and our backup boiler was using 28%. So some of the settings on the backup boiler were aggressive, making sure the house was being kept warm, and it was becoming our primary heat source. So we identified that and changed that, and it substantially reduced our electric consumption just by having that data to be able to adjust to. This is some of the data it provides over time. As I told, it has 3 different circuits that you can go in and remotely control. We have Access European designed fiberglass windows So they open in and they open in and they open up. They've been wonderful, energy efficient windows to have. When we were doing the building and getting them in, the Amish would walk past with their bare arms and just run their arm past the window, just noticing how warm it was in the building without any heat. The windows was probably the greatest delay for our construction. We ordered them early on with a timely delivery scheduled, but one of the windows ended up having a chip in it, and that they were looking for replacement glass, and replacement glass at the time was very tight, and they wouldn't send the total shipment until they had the chip glass repaired. So we waited about 8 weeks in order to be able to get our windows in. This is when we did a blower door test, and this was early on in the process, and you can see we're close to passive. And I had the doors closed, and I wish I would have had them locked because I think our air handling ratio would have been lower with that. We have a carbon dioxide sensor in the house, and if you see up here behind me, you can sitting there that we always watch as people are going in and out of the house. We talked about the solar shingles, and with a certified installer, it took them a day and a half. They did a great job. I'm very happy with that. They put down a template to start off with, and the shingles are installed. And then the installers install the shingles, and the electricians hook the shingles together. Let's see. The electricians have a little iPad that they're using to go along and making sure that everything's working. This was mid-October. It was a pretty cold time doing this, what they looked like early as the installation was being completed. Once more, the schematics of how many shingles coming down into the inverters going off to the generation panel, disconnects back into the house. All the data is there. These are the runs of shingles that are coming down. 28, here's 28 shingles coming down, different ones coming off the roof. So you have all that to look at your leisure later on. These are the gateways of things that looks like outside, coming back into the battery backup. And as I said, we draw down the battery daily to offset our daily use. And then down here, if we turn our water heater off in the summer, we can make it through the night without any backup power. Tesla gives you, our electric control provider gives you information on what's being generated. You can look at the impact of what you're having, and then these settings give you what you want to do for your battery for backup, how you want your car to charge, if there's storm warnings when it comes on, what your utility rate is, how it's paired to your phone, Wi-Fi, yada, yada, yada. These are some information of coming off our home. So blue is always the home, gold is solar, green is battery, and gray is what's happening to the grid. So you can see this is a peak day where we generated 238 kilowatt hours during that day. And that day our home had a couple of spikes. I would guess that's probably doing laundry or car charging one way or the other, charging battery backup, and then here we are using some from the grid. This is just a beautiful bell-shaped curve. I wish every day looked like this. So here we are charging the battery early on in the morning, powering the house, and then this is surplus going to export. Here's the battery being used to power the house, being recharged by the electric, and powering the home in the evening, and this is what's going off to the grid. Grid power, selling back to the grid and a little at the end of the day. So this information is always available. This is with the water heater turned on at night, and you can see that we basically made it through the evening using just battery backup. But this is more common of how a day looks, some sort of energy consumption spike, doing something in the home, getting to be a cloudy afternoon, and this is power going back to the grid. And this is the impact monthly, and all I really want to show here is that this is when the battery backup was on, and the impact that it had of using a lot more energy power, where now we're always up in the 80s and 90s. This is an interesting one. So this is a March 10th of last year on a partly cloudy morning. The power went out, and what time does it say? It was like 6:30 in the morning. And the house was at was using 1.9 kilowatts. The battery had 0.6 of a kilowatt. The power was off for, what does it say, 28 minutes, something like that. And during that time, the battery went from 7% to 13%. So the battery was recharging while the power was out. So it's pretty amazing that it can do it. And you get this notice, and you can actually go in, and if you needed to, reduce power using the smart electric panel, which is pretty nice. Kind of an electric port of showing how we produce more in the summer and less in the winter. Pretty obvious, and our consumption is the reverse of that. So this is 2-year data. We now have 3 years data, but I looked at it and it really didn't change much. What we generated, 127, what the home uses, slightly less than half. The car and what we export. You really can't see anything special on the home other than what Brett mentioned. We have restored prairies. We own 1.1 acres, and we have about 2 acres of city property that we're working with the city to restoring. We have about 3.3 acres of restored prairie around the house. And at some point in time, we're looking at doing vehicle to home or vehicle to grid, or what's called power share. And just because it's cheaper to have a vehicle battery than to put batteries in your house. We'll talk a little bit more about that maybe a little bit later. This is what we wanted on the design of our roof. Here we are with an 8-inch snowfall at 10:30 in the morning, and it's already melting off. And what I found is that if I go out on the roof and I take off the bottom shingles worth of snow, that it sheds snow faster than if the snow holding up on the leaf guard on the roof keeps the snow from shedding off. So like I said, I take the bottom shingle of snow off, and that allows the snow shedding off the roof faster because it's not restricted or held in place by the leaf guard. So this is what it looked like at 10 o'clock in the morning, which means we're getting solar production right after heavy snow. I have a son in the Minneapolis metro area that has solar panels on his roof, 312 roofing, and after it snows, he gets no production until it melts. We also have hurricane tie-down straps on all the trusses down to the stud wall, and it was the most robust tie-down straps possible, and I was the one who installed them carefully. People ask what's your ROI on your investment, which kind of gets my goat. We have solar installation in 2022 when our shingles were installed were somewhere between $2 and $4 a watt. Our cost came in at $2.66 a watt. You know, I always go back to saying, what's your ROI in your boat, your hotel, or your vehicle? What happens if you don't have any power? What happens when it's too hot to work? Droughts, higher food costs, climate, etc., whatever. We added a pergola on the north side of the house to get some shaded space for the summer. This used barn beams off of the old barn that I grew up in. It gives us a shaded, dry entrance on the north side of the house. Here, once again, you can see the heat pump. We have some shiitake logs out here for food production. And you can see the restored prairie surrounding our home. We use the rock that we excavated out our rocky building site for landscaping. This is our rain garden. So we excavated down to bedrock. So basically this is a trench and politely called a rain garden, where water can flow off to the east or water can flow off to the west. And what we wanted to do is we wanted to hold as much water as we could from our site to drain the area around the house and also the rain off the south-facing solar roofs so that our rain did not impact our downhill neighbors. And it has worked very well. Once again, you can see these are the restored prairies. This is looking east and that's looking west. The retaining wall built out of rocks. Again, this is where I had my shiitake mushrooms previously. I did a presentation at the Minnesota State Fair, and the question is, how do you get a 15 by 45 inch shingle into the Minnesota State Fair with thousands of people walking around? So I stuck it in a backpack, and I had, as I was crossing the street into the State Fair, I was swarmed by security who were curious on what I was bringing into the State Fair. So once I told them that, it was fine. And then as we were walking the mile to get to where we had to go at the State Fair, all kinds of people were coming up and asking me if this was a solar shingle. So I finally got an 8 by 12 piece of paper and posted on here a little sign that says, ask me if you want to know about solar shingles. And a lot of people did as we were walking around the State Fair. Kind of fun. Here we are doing the presentation. It was like 110 in the building when we did a presentation that day, no air. We have a QR code sign posted out on our driveway. And this is the video that you saw earlier. And if you're fast, if you have a QR code scanner, you can scan this and it'll bring up the video that you can watch later. Or if you have, this is a handout, you can scan it. So people that are walking by or driving by in their car can actually scan this and get the video that you saw that tells them more information about the house. What you can see, Amish built all electric solar shingles, battery backup, air to water heat pump, main points. You know, I'm not sure how much of this is current anymore about other than rebates. I think the important thing is to look at if you're doing an energy audit first thing to find out where your most cost-effective improvements can be. These are all the contractors that we worked with. That's available if you want that. These are some of our lessons learned. So right now you're looking at electric homes in urban areas make sense. European countries are recommending it. I understand New York State is also recommending it. I understand it works well in urban settings, but in our local cooperative, is only allowing your people to put in 105 to 110% of anticipated needs because they want all cooperative members to have access to electric if they want to, and I don't have a problem with that. That in Minnesota, Xcel Energy and the Minnesota Department of Commerce are now paying up to 50% of battery backup, depending on the amount of power that you're willing to commit during power outages, because they believe distributed generated power and storage is a better, cheaper rate than centralized natural gas peaking plants. This goes back to vehicle to home, vehicle to grid. It makes more sense to do that than to put in batteries that cost you basically about $1,000 a kilowatt to put in. And I saw a photo at one point in time, some community that was small community that was recharging or running their community on backup batteries. And I mentioned that we use our battery to offset grid usage, and that in case there's a NOAA weather alert, the battery backs up to 100% until the alert expires. The Sparrow electric panel basically saved enough money in the first month to pay for it, allows us to control usage remotely. We were part of the ACES solar tour last year, and most of the homes on the tour have somewhere between 15 and 20 kilowatts. Some goes up as high as 20. Ours, if you remember, is 32 kilowatts. I mentioned that the in-floor cooling works and heating works well, but we added a fan coil to address our cooling problems. Not all HVAC companies are willing to work with heat pump. Our air handling system was fantastic to work with. I liked replaceable filters. This was a December evening with bright sunlight, and I was out walking the dog and I'm going, wow, look at all that moonlight on our roof. I wonder if we're getting any production. And I went inside and checked, and there was no readable results. There might have been something, but it wasn't readable. So I mentioned that we had all these different people. There are 20 plus people that helped us design the home. So it wasn't one company. It was a lot of people that were, solar enthusiasts, energy efficient homeowners, architects, people that have built their own homes that had good background experiences that we could draw from. And I'm eternally grateful for them because we're really happy with the results as we're going into 3 years of data. So there are more energy information is available at these different websites. Recurrence is an online newsletter. This was an article that appeared in the ACES Spring Article magazine. Clean Energy Resource Teams in Minnesota did a thorough and in-depth article. This is the video that we're looking at. This is the QR code that gets you there, and that pretty much takes you out of everything that I have. So, Brett, back to you.
Yeah, thank you, Joe. Can you hear me right now?
I can.
Okay, great. Yeah, so thinking about value here a little bit, and well, first of all, thank you for the wonderful tour, and I always love to discuss when the whole is more than the sum of the parts. Like everything kind of coming together is always exciting. Certainly, I love to talk about certain solutions and things like that, but it's always better to see everything come together and see the holistic approach. So again, thank you so much for sort of tying it all together to see how they all come together for the bigger picture of sustainable housing. But value, I'm thinking back to the house you had and the work you did, and then you sold it. And I'm curious if during that sales process you utilized a green appraiser, or the person buying it did, if you're aware of that. And then also carrying forward, if when you were putting your financing together, you likewise did the same for your new build, because I know when you have the green appraisals, you can get a little more borrowing power, a little more equity, and of course more value out of the home sale when it has the sustainability aspects. And just for all of those who don't know, that's all optional. But starting in the fall of 2026, it'll actually be mandatory to start doing green appraisals. So we did a webinar on that last year. I dropped a link in the chat to the UAD 3.6. But anyway, Joe, to your question, did that ever come up in the conversation of both the sale of your old house and sort of the equity increase to, fund your new house to have that green appraisal approach?
Yeah, I think those are good points, Brett. We've worked with green build passive architects on the deep energy reduction retrofit. Mm-hmm. We have some of the people that consulted with our house have a passive house, and they worked with 3 passive architects in order to get the house that they finally wanted. We have another couple that are engineering backgrounds, both of the couple members, and they've been part of this whole team group working together, and they built their house, which is almost passive, but never with an architect. So I mean, I totally agree with what you said. It helps, but we were kind of nibbling around the edges on that with totally knowledgeable people that could help us without going down that road. So I totally agree with what you're saying. Our challenge somewhat was, once we decided to build, we were severely stressed on getting everything put together, because the city council where we live wasn't overly amenable to what we wanted to do. And every month working with the city council, or every meeting where you get bumped back, is a month delay. And we were under the time gun really to go. So the deep energy reduction retrofit on the house that we did we became the ninth home in North America to achieve the 1,000 home challenge, which is to document
Oh,
with
yeah,
energy data a greater than 70% energy reduction. And our
sure.
energy reduction was actually 78%. Now it's quasi embarrassing to admit you, as a residential environmental learning center I worked for 40 years. I was living in a house that I primarily heated with wood for most part, that had
Mm,
was so energy
yeah,
inefficient. But all the resources and the green build concepts, I totally agree with.
yeah. Well, and well, I want to come back to one thing you said, but let's stick back to that value again. So some of the questions, are, of course, how much did this cost? And, and you mentioned you're not a big fan of the ROI question, of course. And, but, maybe, I always ask people to answer that in whatever way you want. We always have to put it into context of, you know, building it, if you had built it to the legal bare minimum code versus the way you built it. Did any of that, are you willing to share any of that in any kind of context of cost?
Hmm. Well, all I know is our cost in 2023 were about 20% higher than our estimates were. Um, so from the get-go, it was a stressful
Mm-hmm.
situation from a financial viewpoint.
Mm-hmm.
Um, when we did the deep energy reduction retrofit on the house, it was the most.
Oh, I apologize. I'm talking about I'm talking about your new home right now,
Yeah,
the home
yeah,
we're talking about here. Yep.
I got that. But
Okay, good. Okay.
the retrofit on our previous house was the most stressful marital time in my 30 plus years of wonderful marriage.
Yeah.
And I wasn't, looking forward to building a new house at all,
Right.
just because not wanting to go through those same stresses. So our cost per square foot were probably about 20% higher than I think what standard was. And my guess is that
Okay.
somewhere that in 2023 came in at about $380 a square foot.
Okay. Okay. Well, thank you for sharing that. That is a very specific answer. So, and so the other thing that you brought up was this council having some issues, and I wasn't sure if you were talking about your retrofit or your new home. But if it was about your new home, yeah, I guess I am curious then, what was the issue? What were the code officials concerned about? In short, and how did you resolve that?
On the old home?
No, no, on your new home. If that's what I didn't know if that's what you were talking about. Were they concerned about, was your local city council concerned about you building this new home, or were you mentioning that concern on your old home retrofit?
Um, I live in a county city where code requirements are minimal at best.
Hmm.
Uh, the
So,
issue with the issue with the city had to do with access. Then I have an 80-foot wide street, undeveloped street to the north of me, and I have a 20-foot
uh-huh.
wide alleyway to the south of me, and they did
Okay.
not allow us to use either one for access.
Oh, okay. So it
And
wasn't related to any of the other sustainability
totally
things you're doing.
correct,
Okay.
correct.
Okay. The other questions, were you get more to that?
Well, I saw one comment on our air handling system not being UL approved.
Oh, yeah, yeah, yeah. We'll get into some of the technical
Okay.
questions here. But so the other bigger picture kind of question was the certifications, energy labels, ratings. Did you do energy labels, any green certifications, any ratings on the house?
No.
Okay.
So we all our lights are LED. All our appliances are Energy Star.
Hmm.
We use the most energy efficient things that were available, but we didn't go into the ratings. I'm sorry.
Yeah, no, that's okay. That was just one of the questions if that was used to help. guide the design, to help you hit your targets, like any kind of energy modeling at all, perhaps?
So yes, we did.
Yeah.
I'm sorry, I reached the age where I have to have things recalled. So we did energy modeling with a company of which I'm blanking on, but yes, we did.
Oh, okay. Okay. And did you find that to be a helpful process to make informed decisions? Do you find that was it accurate? Did you check to see the accurate against your utility bills at all?
No, I didn't, but informational. All those things help. I mean, we wanted to build
Yeah.
a retirement home that would last us the longest, the most efficiently that we could.
Yeah, great. We're going to get into to formal questions here, but before we do, just a real quick reminder to everybody here that yes, this session is being recorded, and you can access it on our YouTube channel. You can check back in the next week, and it will be there, or you can go there right now, click subscribe, and you'll get an instant update. Ring the notification bell when it's available. For those of you watching this in the future, not right now, but on demand, take your quiz with an 80% passing rate to receive your Con Ed. For those of you here today live and you've been here for the entire CEU approved hour, check your spam for certs at gutenbergcerts.com. Over the next week, you'll receive your continuing ed certificate. It'll go into your account. You can check it there, and make sure to take that survey that pops up at the end to get your feedback. We want to hear from you, and that's where you report your AIA number. And as the questions are coming in and we get to those questions, a huge thanks to our board of directors, our volunteers, our executive director, Jose Reyna, and all of our members, nearly 500. We're trying to hit 500 by the end of this year, so help us get there. And all of our sponsors who make products to help meet and beat these sustainability goals, such as Ream, Architectural Resource for Design, Panasonic Ventilation, Build Equinox, Timber HP, and Absolute Solar for our ACES Solar Tour sponsorship. So, Joe, the other question that came in, kind of jumping in to the technical side. Well, there was a very, let me see here. Well, I guess let's talk about your shingles, your solar shingles. Was there conversation about doing traditional PV versus what you did, or using other types of solar shingles? Because there are many different ones on the market. Certainly the ones you have are the most aesthetically pleasing, I think, as far as I can tell. But was that part of the conversation at all? Did you cost compare anything different out there?
When I was my wife and I presented at the ACES conference in Boulder last summer, and there was a solar panel presenter there. And I asked him of his opinion of what percentage of the average roof do solar panels cover? And he said about 50%. You're looking at, they're the wrong size, they don't cover the edges, there's roofs and valleys and everything else. We wanted solar shingles because we wanted that 100% coverage of the surface area. So we really didn't go down the panel avenue at all. Now, the other thing that I know about solar panels, because we had them in our previous house, is that my experience in Minnesota is a solar panel has some sort of metal edge around the panel, and that metal edge is colder and tends to ice up, which prevents them from shedding snow readily. My personal experience, right or wrong, I have no idea, no technical data to back that up. But if you're looking at a flat roof with kind of like what I talked about, the leaf gutters or the leaf guards holding snow on the roof, preventing it from sliding off, if there's any impediment for the snow not to move, it doesn't move as soon as it could. And I want as much sunlight as I can get on my roof 24/7, 365.
Right. Yeah. Now, do you recall if were given a choice on different wattage outputs of the panels, or was it really just one choice?
No, this was in the early stages.
Yeah.
And basically it's kind of like buying a watch or a phone or whatever. You get the vintage of the version of the time that you purchase, and 2 weeks, 2 months later, they come up with a new improved, and you're stuck with what you got.
Yeah. Um, the other question came in was, did you use the same heat pump for your HVAC heating and cooling, or did you have a separate heat pump water heater for that? I think that's what the case, but
So we are using the heat pump for everything.
oh, okay. So it also does your water heating.
No, it does not do domestic water. I'm sorry, I didn't understand the
Okay.
question. So we have a local electric company that gives a super insulated jacketed water heater that we have opted for the most severe limits on the use of the water heater. I think it probably works about 6 hours a day. It doesn't work during daylight hours, and it doesn't work with early morning, evening hours. And I think it probably
Uh,
works from, I don't know, 10 until 4 in the morning for water
oh,
heating. But for two seniors, it works out just fine.
okay. And so this is just a purely electrical resistance water heater.
That's correct.
Oh, okay. Did you?
Ideally, if I had my choice, I'd go with an on-demand water heater. But in
Oh,
southeastern Minnesota, our water is so limey that they haven't proved to be durable for the long term.
okay. And you mean you would have went with a gas one if you had a choice?
No, I would go with electric.
Oh,
So
okay. Yeah,
that's a
don't
good
see those too often. So,
that's a
yeah,
good point, Brett, because we have no alternative energy sources. I mean, we have no natural gas. We have
right.
no wood fireplace or wood heater. I mean,
Yeah,
we're all electric. We drank the Kool-Aid.
yeah. Um, and and was I guess when you were putting your project together, was a heat pump water heater considered at all?
Actually, it was.
Yeah,
And I think the ROI that everyone is so concerned about on the heat
yeah.
pump water heater came back much more extended.
Interesting.
Yeah.
Yeah, that's not usually the case. So that's definitely interesting. So, um, somebody was asking if you considered any solar thermal panels for your edge season for radiant floors, but well, yeah, go ahead and see if you've considered that at all.
We had solar thermals on the previous house. And on the previous house, I worked at an environmental learning center. And on the previous house, we had 5 solar thermal panels installed, if you recall back to that slide on the roof. And it
Hmm.
was installed by a college energy efficiency crew. Um, and with zero level of previous technical skills. And it might have been not the wisest decision in the long term not to go with a professional installer because we had issues with leakages on the solar thermal system. So my experience has been that we had a greater return on investment on photovoltaics than we did on solar thermal. I know normally people say solar thermal is the low hanging fruit. On my particular experience has been that if I had the same amount of money to put in solar thermal or PV, I would have.
Yeah. Well, yeah, I'd be curious who's saying that. I haven't heard that in a long time, and I don't even think anyone installs it anymore, at least not here in Michigan. So they've all
Yeah,
abandoned it.
yeah,
And in fact, just the other day, somebody was text messaging me to ask how they could get their system repaired, and I put out a call on the user group in the state, and nobody even responded. Like, yeah,
yeah.
I'll you can pay me to fix it. Like nobody even wants to touch it. I don't think so. Unfortunately, I think those days are over at this point. So,
Yep.
was ground source technology considered instead of air source in your projects, especially with
No,
the tax credit?
no,
No,
no.
didn't even come up as a thought or a.
It did, but once again, I think the air to water heat pump is a better source than ground source.
Right. Yeah. Um, and
Brett, one
go
other
ahead.
thing, we're like, depending on where on the site you're at, we're like 18 inches to 4 feet max down to bedrock.
Mhm.
And as we were excavating, it's really hard bedrock. Our phone company was looking at doing a ditch witch to bring in the line, and after coring for a day, they had made like maybe 50 feet and just decided to work with.
Yeah. Well, that would explain it too. So, the other question that came in was someone was just looking at your chosen ventilation system, and concerned. I guess in their thought, they thought the filters of a system like that are very expensive. So I'm just curious if that's been your experience, if you looked at different systems with different maintenance costs, or what your thoughts are on that.
Yeah, good question. So on the deep energy reduction retrofit house, we had an air filter that was a permanent air filter, and you could take out some little screen mesh things and clean them off. And they were the dirtiest, most disgusting things I ever looked at in my life. Um, and that the air handling system was in metal ductwork. And as it would turn on, you'd hear it clunk and come on and start up. And we had one of the consultants on our team had the system that we're using. It's quiet, it's whisper free, it's adjustable by numbers of people in the house. And the exchangeable filters is a minor cost in order to keep a good air quality, and it has worked out well, and I'm totally happy with it in comparison to the one with the filters that we never changed. That
Mhm. Yeah, fair enough. And then the question kind of here was, how did your lifestyle change with a house like this? And then more specifically, do you watch the weather more? Do you clean off snow off the solar panels? And you kind of talked about that. Do you run heat more before a storm to store up your temperature before the solar is covered in snow?
you know, a good question. So, my wife and I are late evening pre-dinner discussion always is, how many kilowatt hours do you think we've generated today? So we kind of look at trying to look outside. What are the current conditions? How sunny it has been? And my
Yeah.
wife is getting damn good of probably coming in within 10 kilowatt hours of what our production has been over the course of the day. So that's the
Yeah.
most exciting thing. That because of the passive design we have in the house, that in the wintertime, that the heating system basically brings the floor and the house up to temperature early on in the morning, but it's the passive heat during the day that keeps the house there and that stores us heat that we use then into the evening hours. So we really don't have to worry about heat during the day whatsoever. I really don't worry about taking snow off the roof, like I said, other than that 1 inch or the 1 foot lip or one shingle lip. Um, it's all worked out wonderfully well. It's worked out so well that we really don't want to go anywhere. We live in
Yeah.
Minnesota and we don't want to go anywhere warmer just because we live in a pretty comfortable. Everything is on one floor residence, and it's all the systems are working well. And I think the other thing that you had on your notes announcing this is that the vendors, the subcontractors worked well, and I can't tell you how important that was to have a team that was working well, because HVAC, electrical, Amish builders were just like that. I mean, one would say, I got the stud walls up. I need HVAC and electric in 2 weeks in order to move on, and they had it ready. I mean, it really was amazing how they were all basically out of the same kind of rural area and had worked together on previous projects. But I've been on other projects where it's tooth and nail, where the contractors are off and don't pull back on the site for months at a time. And I mean, we got a house built in less than a year, basically about 7 months from start to finish, and just totally thankful.
Mm, yeah. Well, yeah, those are all the questions I have. And so I think we're going to wrap up on that
Well,
note.
if anybody wants
Go
to
ahead.
come visit, they're always welcome to stop by and kick the tires and see how it's working.
Okay. Yeah. Well, thank you for sharing that. Where can, I guess on that note, then, just a reminder, where can people go to learn more or contact you to reach out?
So there's a all electric Minnesota email address that's available on the information that's available. So they can do that. I just saw a quick question come in if we had slab on grade, but we do have a full basement under the house. So there's
Oh, okay.
1,660 square feet on 2 levels with a walkout basement.
Okay. Yeah, it does. Your home kind of does look like it could be slab on grade on the looking at the view of it. So from
Right,
one of the sides. So
right.
thanks for clarifying
If
that.
you remember,
So
the pergola on the north-south gives us a walk-in door into the basement.
yeah.
Yep,
Oh yeah, that's right. So
yep,
so you have the in the slide in the QR code and everything on there, the contact information and the links where
that's
people can
correct.
reach out then. Yeah.
That's correct.
All right. Well, if I am out your way, I will take you up on that offer. So,
All right,
um,
thank you all. Been a pleasure doing this for you.
yeah, yeah. Thank you so much, Joe, and take care, be well, and stay warm, and we'll see the rest of you next week. So, goodbye.
Be sure to check out all of our courses available online that you can watch anytime and anywhere to pick up your CEUs. Before you go, make sure to subscribe to us on YouTube to get weekly updates and stay up to date on green building science courses, webinars, and home tours. Thanks again.